oh my God, I had no idea that thing existed, and that's how you're supposed to write your program. Why is that button 16 pixels to the left? Don't worry about me and software. I'll pick it up. I can see how engineers work, and I can see how us architects/designers work. And what I've realized is that all programming languages have a, holy smokes, this is not something that I ever thought about. And it's the art of programming, really, designing the right data structure that represents your state. I'm like, oh wow, I didn't really need to change anything. This is interesting. I've never been here before, which is amazing. Like, that's what I love about software.
All right, guys, today I have a very exciting episode, and we have a pyRevit dad himself on the show. His name is Ehsan Iran-Nejad, and welcome to the show. How are you?
Thank you. Thanks for inviting me. Pretty good.
So you've created pyRevit around like 10 years ago, right?
Yeah. This year was the 10th. Well, 2024 was the 10th year anniversary of pyRevit.
Such a long time.
Yeah, I wish we had enough money to throw a big event and invite everybody there and stuff, but that
That
didn't
would be
happen.
cool. I think nobody really knew that it's like 10th year anniversary. I didn't know it existed for this long until I heard it in one
Yeah.
of the podcasts. I was like, wow, no way.
Yeah, it was a personal project for many years. Like 2014 was the year that I started it, but it didn't really catch any sort of like momentum until end of 2015 maybe, or like 2016.
No, but even still, it's so many years since then. This is
Yeah.
amazing. Listen, I'm really excited to talk about pyRevit, but first of all, I really want to focus on your programming journey and see where you actually got started. So I thought that we maybe go back to the moment where you just typed your first hello world statement. Can you just take us there, tell where you are, how old are
Yeah.
you?
So I think I was about 11 years old, 10, 11 years old.
All right.
We used to live in southeast of Iran, and I remember that when I got 12, we moved to northeast to a much, much bigger city. But in that smaller city in southeast of Iran, at the school that I was at, they decided that they want to create a computer class. So they bought this old ass Oliveri computers from somewhere else. I think it was like a university or something like that, that they
It's
didn't need
like,
them. They wanted to upgrade. They bought all these machines, and it was like, I want to say like five, six of them. And that was the first time I actually sat in front of a computer.
all
And
right.
I'd seen him before here and there, like inside banks and stuff like that. But that was the first time I sat in front of him, and I was like, first of all, oh my God, this is cool. Because my dad was a telecommunication engineer, and since I was a kid, like I was around electronics and
Mm-hmm.
machines and things like that. So I was like, oh my God, this is cool. And then the best part was that they started us with a programming language called GW Basic, which is a graphical version of Basic.
Okay.
If you remember the Basic language, you had to type the line numbers like 10, you would do this, to line 20, you would do this, line 30, you would do this.
Huh.
GW Basic was a graphical version of that. So you had commands to draw lines and circles and all sorts of shapes and whatnot, which fascinated me.
And it was still like a terminal back then.
Oh yeah, this is all text-based, sort of like terminal environment. The basic environment is pretty well known for its like blue screen with the little menus on top and stuff like that.
Yeah.
GW Basic had the shortcuts at the bottom, and it was all black. You would just write your uh, commands on the side, your program on the side, and then you hit run, and it would draw the things, and then you escape out, and you change it and stuff like that.
And how far could you push it? Was it just to kind of draw shapes, or what was the kind of the end goal of this
No, it,
language?
it had full basic
Okay.
support, but it had those extra sort of like commands for drawing shapes and colors and fills and those kind of things.
Mm-hmm.
And I remember there was a book that my computer teacher of that class had sort of like shared with us, and it was all this like different star shapes drawn algorithmically. So you would write few lines, and it would draw this like complex star shape out of all these lines and circles and stuff, and like changing colors, and it's beautiful patterns, and that's where my fascination kind of started.
And moving forward from there, how did you pick up your basics? As you mentioned, so you started reading books because back then you
Yeah.
couldn't really go like to on the internet.
Yeah, so that was the first time I touched computers, and halfway through that class we moved to north of Iran, so I didn't have access to the computers again. until like a couple of years later, where I was in high school. In the high school, we had a computer class that we would go to outside of school, and again, it was GW Basic. I was like, give me the GW Basic so I can draw shapes and do graphical things. So I started playing with that and kind of created a very preliminary graphics program that you could just, point to places and draw lines and that kind of things.
Hmm.
And then that class ended, high school ended, and I went to university. Well, the study year for university, the year before and stuff like that, didn't have access to computers again until I was at the second year of university, second year of architecture school, where I was like, I kind of need my own computer and I need AutoCAD and a whole bunch of other stuff. And that was the first time I was like, I think it was like 19 or 20. That was the first time that I got my own computer.
Hmm. What year was it? You said you were 1920, but
This is 1999, 2000. This is actually 2000.
okay, 2000. All right.
Yeah. It was around like 2000-ish that I got my own computer. And I remember it had a decent graphic card at the time. It was a Savage card. And most other computers didn't really have a graphics card. And I had a
Hmm.
modem, things like this that was like super cool at the time.
And at this point, you still kind of played a little bit with code, but you were not like coding some projects all the time or something like this, right? You just had little understanding at this point.
Yeah, so one of the things that I did was that when we moved to northeast of Iran to the bigger city, in that second computer class that I was at, I was like, I like this enough, and I can see how fascinated I am with this. So I knew basic at the time
Hmm.
through that class, but I was like, I need to learn something better. So there was this computer like technology bookstore in the city, and I went there and I saw a book that says C programming language
Hmm.
by Dennis Ritchie and Brian Kernighan. And that's a very famous book. It's like a Bible for programming. It's called the KNR book.
Hmm.
This was a translation in Farsi, and I was like, oh, this seems interesting. And I looked at the writing, and I was like, this reads easily. I can understand this. So I started reading that book, and I taught myself how to learn C. But I didn't have a computer, so I would like write all these programs on pieces of paper and go through them in my head, imagining that they would work. The first time that I actually got to experience all of this was when I had my own computer to kind of sit down. And after CO, I started learning a little bit of assembly and but here and there, like I would go work for companies and they would have a computer and like after work I would try a few things out to kind of test out my programs and stuff like that. But it was really when I got my own computer that I had a programming environment in front of me.
And at this point, you haven't still started with Python. I think Python didn't exist yet.
Oh no, 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 this is way before. Yeah, this is before Python.
All right. And when does the Python come into the picture? So you started with this graphical language, then assembly, basic, C.
Yeah, so I went to architecture school, second year, got my own computer, started programming. Very quickly realized I like the more technical side of architecture, and I'm not on the very artistic side. I'm more like on a little bit of a technical side. So
Hmm.
I spent a lot of time with the computers and learning different softwares and working for different companies. Like I worked for publishing, graphic design, like all sorts of stuff, electronics with my friend, all sorts of things around the computer. Computer was always in the center of all of this.
Hmm.
And then we moved, and like throughout this time, I learned C programming language for embedded microcontrollers. So I was writing C for chips like ARM chips or Atmel chips. And then I had a friend that he was an electrical engineer. So I taught him C, and he taught me how to use electronics, digital electronics mostly. And we would kind of like start doing projects and stuff together, which was a lot of fun. I
Yeah.
still haven't touched Python at this point. I knew it existed, but I really didn't touch it. And then I moved to the US, and while I was working here as an architect again, I kind of realized that spending time writing C and stuff takes a lot of time. So I kind of needed something that's a little faster that I can use it as a scripting language.
Hmm.
And by this point, Python was pretty famous. Python 3 was already out. So I started picking up Python. So this is sort of like around like 2011-ish, which I started learning Python.
What kind of problems have you tried to solve with the programming language? So what was your why reason learning programming? Was there like specific problem why you decided like, okay, this is the Python or
Well, part of it was always that I loved computers so much that I was like, anything I can do to spend more time with these machines. And then the other side was that I have a lot to do in my day. Like, for example, I remember one of the things that I automated with Python was that sending emails to my boss, because I would supposed to every morning when I come to the office, I would go through all these like government websites looking for jobs, and they come with a pretty standard format. Like, there's an RFQ and says like what kind of job it is and blah blah blah. So I would go through and pick out the ones that I thought it would be interesting to him. But then as I would download all these PDFs, I needed the standard format to send emails to him. So I wrote a Python program and I would grab this PDF and throw it in this Python program, and it would automatically send emails to him, which he
Okay.
hated because like he would get like 20 very well formatted emails right after each other really quickly.
Look like spam, right?
Yeah, I was spamming the inbox with valuable information, arguably. But
Uh,
like I started doing that, like renaming files. Python started really quickly becoming the Swiss Army knife thing.
yeah, I see. All right, and you said that you started Python, you were already in the university, right? Or it was already after?
It was after the university. It was
After
when I moved to
university,
the
right?
US. Yeah, I was working as an architect at this point,
All right.
2011-ish, primarily in AutoCAD, doing stuff on the side at home, like learning Python. I
Mm-hmm.
knew Maya, a little bit of Maya, so I was writing like C++ programs, plugins for Maya, exploring an environment. Because I had touched Grasshopper before,
Mm-hmm.
inside of Rhino, but I didn't have a Rhino license. I had the Maya version, and I was exploring like writing plugins for it to create like geometry generatively, things like that.
And where does Revit come into the picture? Because so far it sounds like you haven't been working or studying using Revit, right?
Yeah, this is all before Revit. When I moved to inside of the US, I moved to Portland, where I live now. And when I
Mm-hmm.
started working here, there was this company that I got a job with, and they used Revit heavily. And on the interview, they asked me, "Do you know Revit?" And I was like, "I've done a little tiny project, but I'll don't worry about it. I'll learn it. Don't worry about me and software. I'll pick it up."
Mm-hmm.
And they're like, "Sure." So when that started 2014, and it was Revit 2014 is the first one that I started working. But the end of that year, I had the first version of pyRevit because like I couldn't work coming from AutoCAD and all the other programs that had scripting languages. It was really hard for me to work in Revit and do anything.
All right, so you started in Revit, and by the end of the first year, you hated so much you started creating
Yeah,
PyRevit to make
yeah.
it
It
better.
was like mid through 2024 that I'm like, this is not gonna work. So I found Revit Python shell, and I started writing Python scripts and kind of learning the Revit API. I was like, okay, this is great. I can. It's bringing my sanity back to me. So I would like run area calculations in my own scripts automatically, and my boss would sit beside me and we would go through the plans, and I keep running this. And he loved it so much because he couldn't do this with anybody else.
Mm-hmm.
Like I was showing him
Sure.
live information that was hard to get from like Revit schedules. And those scripts that I wrote basically became the first draft of pyRevit tools.
Mm-hmm.
They went into I figured out a way to put them in the ribbon. And the first version of pyRevit had monsters for the icons for all these different tools, and each one of the monsters was specialized in an aspect of the like sheets and blah blah blah, which those later became the panels and that kind of stuff.
You had like a screenshot or something from your first PyRevit
I
toolbar or
really
something?
tried to find stuff, but I can't. Well, you can go back like in the repo is there. You can go back all the way
Oh yeah, actually,
to
yeah,
the
I can.
original commits, and all the icons are still there somewhere in the history.
I need to check what's going on there. It's actually quite interesting. So, and by this point, was Dynamo even in the picture for you? Have you used Dynamo with Python nodes?
No, not at all. I was sort of like I was a lot more interested. If I want to simplify it, I'm sort of like frameworks kind of person. I like to make tools that other people use to make tools.
Mm-hmm.
So I saw Grasshopper and I was like, this is fascinating. And I learned how it worked. And I'm like, okay, I know what it does now. I can move on to other things.
Mm-hmm.
And then when Dynamo came out, I looked at it. I'm like, I've seen this before. Like this is not even as good as Grasshopper. So there's no reason for me to spend time here. When I started working with Revit a little more, I was like, maybe this could be the platform that I could, make things in. But it was missing so much that I was like, I'd rather just do them in the Revit API and have
Mm-hmm.
a cleaner, simpler environment with no plugins and stuff like that versus like a lot of dependencies.
So I have a question. So you're already familiar with so many languages, especially C. Why have you decided to create PyRevit instead of just using C# and making it natively, like native Revit plugins?
The biggest drawback for me was that, first of all, I absolutely love Python. I think it's like, for me, it's like the perfect programming language. There's no such thing, but like, it works for me. The C sharp, I don't like that language. I don't like programming languages that are very complicated. There are many ways of doing things. In Python is very simple for you. You just
Yeah,
write a bunch of functions and write a bunch of data structures. That's all you need. It's very much like C in that sense. So I had an aversion to like that's what I never really learned C++. plus plus. I learned it, but I was like, I'm fine with C. I don't really need to deal with this because like all the templating systems and it gets very complicated. And I know
yeah.
it has powers.
Does C also have memory allocation like C++?
Yeah, yeah. C
Oh,
is
yeah.
you're in C, you're basically in charge of everything.
Okay.
There's no runtime in C.
Mm-hmm.
It's just a standard library and it's you. But it's such a simple programming language that with like a couple of patterns, like how you would deal with the memory and how you would with the file I/O and stuff like that, you'll be pretty fine. I wouldn't suggest like writing programs in C these days. It's a pretty complicated language. Like if you want to use, I don't know, send an HTTP request, it's gonna take considerably more time in writing that in C versus Python. So
Mm-hmm.
no, you're not going to be as productive. But um, Python was kind of like that for me. It was simple. I didn't have to think about the how I want to structure the program. I could just write a bunch of functions, throw them in a module, and have a couple of different data structures and start working with them. C sharp, I had a hard time doing this in object-oriented environments in C sharp. I kept like I to this day I still fall into this sort of like loophole of trying to structure all this nesting of the classes and which function overrides the other one, and there's that kind of stuff. So I spend more time figuring this out rather than actually writing the code.
Mm-hmm.
Um, so the problem with me with C sharp was that I need to have Revit open, and I have a project that takes about 15 minutes to open because it's so big. And
Okay.
I wanted to write some tools to make stuff, in this to automate things in this project. But then if there's a bug, I need to close Revit, make some changes, compile the plugin again, load Revit again, open the project, run the tool. That cycle was too time consuming.
Mm-hmm.
Python completely removed that cycle. If I had a script in an empty script in a place and I would run Revit, that script will show up as a button in the Revit UI. And I could keep just changing that same script while Revit is running and just clicking and getting different results.
Yeah, this is what's so amazing about pyRevit, that you instantly, like, you run it, you get an error, you go change one line, back and
Yeah,
forth. That's pretty
yeah.
much how I also develop, constantly getting errors, fixing back and forth. Oh, now it works, and I'm happy.
Yeah,
Interesting.
working as an architect, then that sort of like time-consuming software development cycle kind of didn't work. Python solved that problem. Python inside of Revit.
I'm not so familiar with C Sharp, but I keep hearing that many people say, C Sharp is still faster than writing in Python. Do you have any thoughts on that?
Yeah, so like over the years, I've looked at a lot of like different comparisons between programming languages, and a lot of it comes around like performance and memory efficiency and those kind of stuff. And what I've realized is that all programming languages have a sort of like a mind, have a sort of thinking, a way of thinking about them. And if that way of thinking aligns with your way of thinking about writing a program, it's gonna be a good programming language for you.
Mm,
So like there are people that love C sharp, love object-oriented programming languages. The people that don't, like I'm not a huge fan of it. If I try to stop myself, actively try to stop myself, not going more than like two levels deep inside in class hierarchy. So if I have a basic abstract class, I only do like one derivative of that. So that
hmm
creates like these two levels for me, two layers. Obviously, I fall into this pattern all the time that I'm like, end up having like really deep nests, and you can't figure out where something's happening. So it's hard to really compare programming languages. But in terms of just performance, like raw performance, Python is written in C. So, and it's an interpreted language. So as it's running, it's interpreting the instructions that you have written in the Python file and executing them one by one in a loop that we call the Python interpreter loop. So there's a loop running inside of this C Python that runs
hmm
these instructions. C sharp, it's sort of similar. It reads your instructions, which is your C sharp code, it translates them into this intermediate language, and then saves that in a DLL, which is your program. But
Hmm.
when it's actually running those, it takes those intermediate language, the IL code, and translates it into machine code, which we call JIT compiling, just-in-time compiling.
Hmm.
So when it actually runs your code, it doesn't go through an interpreter loop. It runs the compiled code for the machine that you're running on. So it runs on CPU really. So when it runs as fast as any other program that runs on CPU. Python has this duality to it. The code that you write in Python runs in that interpreter loop. But if you write C Python modules like NumPy and SciPy and all that kind of stuff that are using the Python C API, that interpreter loop calls into that module, and that module is free to do anything on the CPU. That's why NumPy is so fast, because
Hmm.
it's not inside Python's interpreter loop. SciPy is so fast. You see TensorFlow. You see all these really sort of like complicated, extremely fast numerical libraries show up in Python first
Yeah.
because it had this connection to it that you could write on the surface. You can write this simple code that goes through the interpreter loop, executes very easily. Error handling is great. But when it needs power, it passes the control to that module and says, go do your computation. Let me know when you're ready. This was the beauty of Python, this duality of Python, that
Hmm.
it's a scripting language, but it has a plugin that makes it as powerful for like scientific languages and all that kind of stuff.
Yeah, I see.
You could do the same in C Sharp if you have a very good mathematical library. I would say they run as fast as each other in majority of the cases.
Thing is just that Autodesk has C Sharp more optimized because they don't really do anything for Python. And Python, pyRevit also needs a lot of work right now to kind of get it up to date.
Yeah,
Fix. I
yeah.
recently spoke with Jean-Marc. They want to make a lot of changes to make it faster, but it's all about the manpower.
Yeah, when you run a compiled program using like languages like C++ and C Sharp and stuff like that, shipping that language is a little bit easier because you don't need a runtime in theory. Like if you write a Revit plugin, Revit guarantees that the runtime, the .NET runtime is available, right?
Hmm.
But when you write a program in Python, you the Python application needs to be on the target machine to be able to run that. That's sort of what pyRevit started guaranteeing. It's like I
Hmm.
guarantee that IronPython is going to be there if you share your scripts with other people. That has to be the general problem around Python, and it still to this day is a little bit of a problem. Deploying part-time Python application is not as easy as compiling a C Sharp application into an installer and send it to somebody.
How hard would it be to create kind of Python plugin and ship it as the C Sharp plugin? You know, like with this installer, like you're talking about, is it
Mhm.
even viable in Revit, or you need like completely rewrite pyRevit as your own thing first?
If you want to run that Python code, you need to have the Python runtime available.
Mm.
So like this is kind of what I do right now with Rhino. In the new sort of like Rhino 8, I created this new script editor. We decided that, the older script editor have been around for too long. We needed something that's a little more modern. So we created this new script editor that has IronPython and Python 3.
Mm.
But the problem was that like if I have a script, how do I share it with other people? So we created this mechanism that you can have a bunch of your scripts inside a project and you publish this as a Rhino plugin. So it gets compiled as like an actual .NET DLL, but it embeds your scripts inside of it somewhere.
So you pretty much
So
can share all your code as a package.
as a package with somebody else, yeah. As long as they use the same Rhino version and above, right? Because when that
Mm.
DLL gets loaded, it requires this new scripting infrastructure to say
Mm.
that I am carrying a Python 3 script. Can you run this for me as this command?
Yeah, yeah,
Again,
sure.
guaranteeing that the runtimes exist.
Yeah, that's quite deep stuff. I'm far from going that deep in coding. My Python is pretty good, but once you go into these compilers, runtimes, I'm a little bit lost myself. But when you created PyRevit, how good were you with programming languages? Would you say you already were like an expert?
No, not at all. I'm still not a very good programmer. Like there are a lot of people that are much, much better programmers than me.
Oh,
Like at the same company that I'm working on, like every time in the dev meetings, I'm like, oh my God, I had no idea that thing existed, and that's how you're supposed to write your programs. Um, but for me, it was like I've never really, like I'm not very good in math. and I wasn't really good in the sort of like the algorithmic, complicated computer science aspect of programming. For me, the fascination was that, hey, look, I can put a bunch of commands together and make something happen. And that's why I
Mm.
love the scripting languages a little more. This at the time that I was like spending time on microcontrollers and stuff like that was slightly different. Microcontrollers are a lot simpler. So you're writing C, but you're in charge of everything, and it's still fun, and you're putting things together, and you're controlling timers and watchdogs and stuff like that on your microcontroller, and it's a lot of fun. So I wouldn't call myself a good programmer, but that didn't really stop me from, putting together 20 lines. As long as you understand how variables work and how a couple of control flow structures, like ifs and switches and for loops and stuff like that work, I think you can put a lot of good, useful things together. The
Hmm.
hardest part doing thing on Revit hasn't been the programming language. It was like dealing with the Revit API. Because there's
Hmm.
this thing that you want to do, and you're like, it kind of doesn't do it. So maybe I can do it this way. I can do that first and then do this first. And then as you're doing this, you're like, oh, it breaks when I make the first change, or I'm going to need this other thing. That
Hmm.
cycle is the one that takes really the most time. It's not really the programming language itself.
Hi, real quick. If you're into pyRevit and you want to boost your skills in record time, then check learnrevitapi.com platform. You'll find free in-depth courses for any stage of your programming journey. You'll get access to pyRevit Basics, Pro, and Modern UI courses. Plus, you'll also get access to my code library and join my exclusive community for pyRevit developers. In the community, we can chat, discuss programming in Revit, and most importantly, you can ask for help when you need it the most. If that sounds interesting, go to learnrevit.com to learn more. And now, back to the
I like
show.
to say that programming is pretty much just a skill about problem solving, not the coding. Coding is just what we use for solving problems. And in the end of the day, code is just kind of a step by step instruction. There's a really good video on YouTube. I don't know if you've seen. It's called How to Write Exact Instructions. And it's a dad who just asked his kids, okay, you have to write me instructions how to make a peanut butter sandwich. And they were saying like, okay, take the knife, kind of put the peanut butter on the bread. And he was literally
Oh,
follows,
I've seen
yeah.
this, and he follows the awkward instructions of this. Yeah, it's really cool. Yeah,
Yeah, and it looks so stupid, but in the end of the day, this is how machines look at our code. And
yeah.
oftentimes when we write a code, it doesn't work. It's probably because we just didn't think about some step or it's just not exact instructions. And yeah, that's what programming is for me. And many people focus too much on the code itself.
There are a couple of old school programmers from like 1960s and 70s and stuff like that that were involved in creating the Unix programming language, the operating system and the C programming language and all of that. There's stuff that we still use today. One of these guys said something that resonated with me. So your program has only two things. It either has logic, which is, let's say, a function that computes factorial of a number. That's just logic. It's pure
Hmm.
logic. Or it has a state. So it's holding something in memory and you're manipulating that state. That state might be the
Hmm.
state of your UI. Things change and you need to disable and enable and update. So at every point in time, your UI is at a very specific state. And this state is represented in memory somewhere.
Hmm.
And your logic, the pieces of logic around your code are mutating that state, right? The art of writing logic is just good math and algorithms and studying algorithmic performance and things like that. So you write the piece of logic that runs as fast as possible and it does the thing. And I don't know, like, and it depends on the task that you want to do. Like, it depends
Hmm.
on what kind of, like, if you want to pick a sorting algorithm, it depends on what you're trying to do. There are like a bazillion different sorting
Sure.
algorithms. So that's part is fairly clear. The part that's unclear, and it's the art of programming really, is designing the right data structure that represents your state.
What do you mean by that?
So let's talk about the script editor that I made in Rhino 8.
Hmm.
This is something that I sort of like started learning. It was the biggest UI that I ever made, UI application that I ever made. And it was the biggest C# code base that I ever worked on. So I was learning this as I was going through it. The script editor has a bunch of codes open and a bunch of panels with some contents, and there's like Explorer on the side, and there's a whole bunch of commands running in this application. It's not just the UI that you're seeing that has a state. There's like all the commands that are in the memory
Hmm.
that are about the editor.
Yeah.
and all the panels that you don't see that are not visible in the UI maybe. Like a whole bunch of other stuff is outside of this UI that needs to be at the correct state at the right time. And meaning at the correct state is that if I have a toggle breakpoints button in the breakpoints panel for the debugger,
Hmm.
if I don't have any breakpoints in the script, there is no reason for that button to be active. That button should be disabled because it doesn't really do much, right? And the disabled enabled is the state of that button.
Like event triggers.
Yeah, yeah, exactly. So as I'm debugging the code, if suddenly my toggle debug breakpoints button becomes disabled, that's a bad state. That's
Hmm.
not supposed to be there. That's a bug, right?
Yeah.
So maintaining that state as the state of other things are changing is really complicated. And you have to create this data structure that represents this, as we call it in a sort of like the UI world, we call it the view model or the model for that editor. This
Mm.
model that represents the editor conceptually. And there's a place on it, there's a property that says um, breakpoints button enabled. And there's a property that says, like, do I have breakpoints in there or not? And internally, these two are tied to each other.
Hmm.
So when the breakpoint changes, it also changes this. So this data structure internally manages its own state. If you add a breakpoint, it enables the breakpoint button, things like this.
So talking about MVVM right now, this pattern, model view, view model, right? That you have connected code to like interface and it's all kind of interconnected.
Yeah, I'm using UI as an example. That's why sort of like
Hmm.
the conversation goes a little closer to the MVVM models. But this is about everything that you're trying to do. Like if you're writing a data structure that's supposed to hold a list of employees or something like that. Those are like typical examples that you see in programming languages.
Hmm.
You could use a normal basic data structure like a list. But then, like for example, if you want a certain number of like your principals that are listed in employees to be
Hmm.
listed separately, you might encapsulate this list in a data structure that knows how to deal with the principals list, things like this. So it's
Hmm.
the art of that creating that as data structure that represents the thing that you're trying to deal with that is really the art of programming. If you write that data structure correctly, if you kind of figure out how it's supposed to be, working with it is very easy because it's very
Hmm.
intuitive at this point and it behaves the way it's supposed to behave.
So it's also kind of going back to this choosing the right design patterns and most importantly deciding what you're trying to get out of
Yeah,
it. Because
yeah,
sometimes you're trying to make something simple and it doesn't make sense to go into object-oriented programming. But
yeah,
other times it actually makes sense to go into object-oriented programming instead of this functional when everything is interconnected and you,
yeah,
yeah, I see it. It's definitely very important to kind of decide on what you're trying to achieve before actually jumping in, because that's what many people do. They first jump in, they start doing, and then halfway through they realize they're using. Well, it's not gonna work because they decided to do something certain way. At least that's how
yeah,
I did certain things. I jumped into creating some plugin with UI. I didn't know anything about MVVM, VPF. I just decided to spend a couple days on the UI form, and I realized, oh, actually, I started everything wrong. Everything started to break because I just didn't think through what am I doing here.
yeah. And that's absolutely fine. Like, that's one of the other reasons that I like Python so much. Because you can, like, let's say I'm creating something in Revit, I can just start a script and start fiddling and trying to figure this out.
Hmm.
And like, if the art of programming is writing that perfect data structure, you're not going to know that data structure right off the bat, unless like it's super simple. So you have to
Hmm.
go in and write a bunch of like very bad versions of the way you're trying to do
Hmm.
things, and you're like, yeah, this is not supposed to work like that, so I'm going to make a change to that. Over time, you'll kind of understand the full scope of this thing that you're trying to create
Hmm.
or deal with, or
It's like in the end, whenever you write any big program, then you have a look at it and you always think, "Oh, man, I should have done it differently, this or that." Then you rewrite it and you still have the same thought that you want to again rewrite it differently. I don't know, do you still have this kind of thing when you kind of finish kind of big code and you look at it and you want to do it completely different or just rewrite it?
yeah, oh my God.
It never goes away, right?
Yeah, that's what I'm doing right now. It gets a little questionable, like how much you can change. But a
Sure.
lot of like I wrote a bunch of bad code inside of the editor because I didn't know how to do this better. So I'm like going now after a couple of years, I'm going cleaning that up, making sure it runs as fast as possible, that kind of stuff. So rewriting those. And I was reading, I was watching this YouTube video of a guy that was a programmer, and he suggested that limit the size of every chunk of your code to about a week worth of work.
How big chunk are we talking about? Is it like a file, a class?
Depends on how you structure your program. Like, for example, if you have a module that's supposed to talk to your web server, make that as big as about a week worth of work. So if you realize that in the future you're going to need to change it, it's about a week of work. And then you can replace that module. So modularize it in this way, and there's sort of like separate components, abstracted components. So you could replace each one of them in about a week of work and make it better or use a different backend or, that kind of stuff.
There's this principle that tasks always take the time that you allocate to it. Meaning that if you're gonna, let's say you have to write an essay, if you're gonna give it a week, it's gonna take a week because you're gonna write it in the last day anyway. If you have 24 hours to write it, you're gonna write it in 24 hours. And I think this is also a good thing, like you said, that the chunk should take, for example, a week. Once you give a time constraint, your brain also knows like, okay, there's like a ticking time. It starts things also differently. I think that's
Yeah, that's
really
right.
good.
Yeah, that's a good point. Yeah, just thinking about it that, hey, I don't want to write a big chunk of code is also helping you focus
Yeah,
on
yeah.
what is bare minimum requirement for you, for that code at that time.
Right, interesting. Also, we got away a little bit from pyRevit. I want to have a few more questions.
Hmm.
First of all, what were the biggest challenges creating pyRevit? Because at first you took Revit Python shell and you decided pretty much to make it into, how to say it, reusable extensions, right? So you can put all your scripts in the toolbar.
Yeah.
What were like the biggest challenges in the first, I don't know, year or two of creating it?
The first year or two, the biggest challenge was really there were two things. The first one was how to get all these Python scripts to show up in the ribbon,
Hmm.
which I learned from Revit Python shell. So I was like, okay, Revit Python shell does this. I'm gonna copy exactly what he did and start creating the buttons. That sort of like that was the first draft of pyRevit, which I solved that problem. But after that, it's been always deployment, like packaging all of this in a installable and send it to people that have different responsibilities. Somebody's an admin, somebody's not an admin, somebody wants these tools, somebody doesn't want the other tools, like all sorts of stuff. Finding a way to get this program installed correctly on the target machine has been a huge challenge. And I kind of blame Windows for a lot of this, but it has been a big problem. That's part of the reason that sort of like pyRevit attaches itself to all the different Revit versions because I didn't really want to deploy pyRevit for 5 different Revit versions at the same time. 'Cause I'd
Yeah.
rather have like one pyRevit installed that I can deal with. Because like if like imagine there's a customer that asks you a question on the forum and he has like 3 different pyRevits installed for 3 different Revits.
Oh, yeah.
It becomes kind of a nightmare trying to figure out.
No, I think it's just a ticking time bomb, right? At a
Yeah,
certain point, you stop kind of supporting one version, but the other, and
yeah.
like the hell broke loose.
Yeah, I would say every other challenge has been fun. They're like little challenges. How do you do this? How do you do that? How do I like update pyRevit using Git and stuff like that?
Hmm.
But then it's fun. You go through it. You spend a week or two. You kind of figure it out, and it's okay. The challenges that gave me a lot of headache, like one of them is just deployment, creating an installer for pyRevit.
No, I can imagine. Every time I hear Jean-Marc talking about this, I kind of, my brain a little tunes out about all this deployment, how to make this, managing keys. I'm like, it's kind of foreign to me. I know what you're talking about, but I don't know like this good understanding. Would you do it much different if you would had to do it today? If you would kind of start pyRevit? Let's say that pyRevit didn't exist yet and you decided today, like, all right, I actually want to make it. How much different would it be?
Um, yeah, I would. So there's a part of pyRevit that goes around the your local drive and starts finding all these scripts and loading in the Revit UI and stuff like that.
Hmm.
I would definitely write all that in C sharp. Like just
Hmm.
make it as simple as possible. So that removes a lot of like Python code that gets deployed to the machine and it would run a lot faster. So the discovery of the scripts would be a lot faster. And then it gives me the flex, because it's fast, it gives me the flexibility to start having a bunch of listeners and stuff. So as you change the layout of the scripts in the folder, the UI can readjust itself to represent that layout, stuff like that. So I would absolutely rewrite that part. And then I would keep everything about the Python the same. So the buttons, the way like the bundles work, all of that will stay.
Oh, it works amazing. It's the simplest you can imagine.
Yeah, I think that part is fine. That part is what people like it and it's easy to use and like just throw an icon in a bundle and it shows up in Revit. That's great. And then the other thing is Python 3, which the one that we have in pyRevit right now barely works. It may be useful in some instances and stuff. But I spent the past 4 years trying to make Python 3 work inside of Rhino. So like I would bring these experiences and those changes to pyRevit, to the new pyRevit, so it has Python 3. I'm not sure if it would need really Python 3 inside of Revit environment. I think IronPython is doing a very fine job. And there's not a whole lot of people that want to run TensorFlow inside of Revit.
The NumPy is a big one. Actually,
Yeah,
quite a lot of people interested in Python 3. Some people because of the UI, because there are some packages in Python 3. Majority I hear about NumPy. What is it? Not Matplot.
Matplotlib.
Pandas definitely
Yeah,
for working better
Pandas,
with
yeah.
Excel. So NumPy and Pandas all the time. People ask me now about this one. I've shared how to do it, but I also mentioned like 5 times during the video, like this is not like in final version. It's still buggy. Watch out. Also interesting because I just talked to Jean-Marc and he said that for 2025, one of the big things for pyRevit they have is actually rewrite this thing in C#, like you said, all this loading of the folders and kind of improve the speed and stuff. So I was glad to hear that there's already, you right away pointed it out. And he also mentioned this as a big point on their to-do list.
Yeah, I think at this point, pyRevit kind of needs that to like load faster, like as the tools. Because one of the things about having a scripting environment is that you would end up having a lot of scripts for different things. You have like, copies and copies of these scripts that do slightly different things. So it's important for that environment to be able to load all of this a little faster.
I think the latest Revit API change since they migrated to .NET 8, I think this was like a wake-up call that, all right, a lot of things need to be reworked. It's all about the manpower. Because pyRevit, well, at least Jean-Marc, it's really good what he's doing right now. He's pushing, kind of looking for people, collaboration, putting a lot of effort, kind of organizing all this stuff. This is really good.
Yeah, these guys were the godsend because when I started working at McNeel, I thought I can work on the editor and pyRevit at the same time. But once I started getting into the editor stuff, I was like, I'm way over my head. Like, I don't have time to do anything else. And that's the time that sort of like they started digging in and getting a lot more involved. And we're at the point that it's a organization run by them at this point. Like I don't do anything in pyRevit anymore. I don't write code for it anymore. I just help out if they need anything, but they're pretty much self-sufficient at this point. Like I didn't do anything, pretty much anything for the transition from 2024 to 2025. It's all them, which is amazing.
No, I definitely have huge respect to the team because they are all working kind of part-time for fun. Because many people also mentioned with Jean-Marc that don't realize that pyRevit is not like organization, company, for profit. It's just a bunch of people who are excited about Python. They work in Revit and they want to make it possible. This
Yeah.
is what kind of keeps this project alive. Right now, Jean-Marc is planning a lot to kind of get the funding pyRevit needs, to kind of hire developers like C#, just at least part-time for a couple of weeks. Like, okay, here's the tasks, please do it, just make it better. And so this is what I understand is the goal for pyRevit right now, which is great to hear.
Yeah, it's been amazing. I'm first of all, I'm honored that there's like a bunch of people that decided that this is something that they want to keep alive. Otherwise, it wouldn't be dead. The other part that I'm really happy is that people are working on it that are actively using Revit every day. I think that's absolutely like you should not make software that you don't use. Like one of the challenges that I have at McNeel right now is that like I'm not using Rhino actively every day for creating things. And I'm writing this script editor part that I'm not using actively in production every day. And so I'm blind to some of the important ways that this is used and the annoying points about it and how it could be better. So I kind of rely on the feedback of the people on the forum. that they
Hmm.
come and say like this is not running as fast as possible, like this is not supposed to be this way, this doesn't make sense, that kind of stuff.
Yeah, it's always the little things that matter. Even
Yeah,
though you think it's not that important, sometimes this one little thing can make people so much happier, just the way it
yeah.
works, right?
And it's people build muscle memory. Like Python, Rhino has this editor that's been around for like 10 some years, 15 years. And when I walked into Rhino and I was like, Steve said, we want to put Python 3 inside of Rhino. I was like, great, can I have this project? And he's like, yeah, do you want to work on it? Keep working on it. So we kind of realized with the transition to .NET, the old editor wasn't really working either. So we kind of need to create a new editor that is consistent, especially with Windows and Mac. Because like Rhino Mac didn't have anything. It had a text box for the script editor and a play button. Um, so once we started working on this, I kind of realized that the I had never really used the old script editor in production, so I didn't really exactly know how this script editor is being used. And it's a lot and beyond what you can see in the UI and what you can see in the code. It's all those nuances of like how people are used to writing, doing things. So the moment I introduced like Rhino 8 came out end of 2023, and the moment people got their hands on it, they're like, why is that button 16 pixels to the left? Because I have built this muscle memory with my mouse that I can just go click that button and it's not there. And or like it shows a prompt now
Yeah,
instead of just closing and whatnot. And I was like, holy smokes, this is not something that I
yeah,
ever thought about. That it inflicts physical pain on somebody when you move a button like 16 pixels
yeah.
on the screen.
Doesn't make any sense, but it's such a big deal breaker. This is why in UX everyone is afraid of new designs. This is, I think, I heard some story somewhere. There was a developer talking. I don't remember exact story, but the point was like everyone was complaining how bad the software, everything is buggy, and so on. He did nothing to the code, and I think he just told them like, this is we did this and that, like internally we changed the engine or something like this. He didn't change anything. Everyone started writing positive feedback. It's amazing. It's so much better. Finally, he was like, I didn't do anything. I just kind of gave you the placebo and you just took it. Like, and he was just showing that sometimes users don't know themselves what they want.
Yeah, it's hard to because I feel at this point in my life, after being 5 years on the McNeel forums, when I started working there and I would get all these negative feedback, I would take it personally. I was like, oh my God, I'm a horrible person. I broke people's stuff.
You moved at 16 pixels.
Yeah, they can't do their work now. But now, after all of this, I kind of realized that I need to get past that and sort of like read what they wrote, the problem, and kind of start going beyond that. And like, what is the actual problem there?
Hmm.
It's not, it's a lot of times it's not what they're asking. It's somewhere deep
Oh, yeah.
somewhere else. So you kind of have to have this back and forth and get him to give you an example or a sample that's repeatable or and ask you questions about how do you use this, like, to use this first, to use that first, that kind of stuff. So that communication is incredibly important to kind of figure out why they hate this so much. Is it
Hmm.
really because the button moved, or is it because like the button is not prominent enough, or because like for other reasons? Finding that out is has been it's actually quite fun. I enjoy that on the forums now.
Okay.
When I go to the forum and like somebody's like, "Oh, this is not working," I get excited. I'm like, "Ooh, there's a new challenge that I need to fix."
You're like detective going in. All right. Time to crack your subconscious. What did you mean here?
Yeah, yeah, exactly.
So I talk quite a lot about McNeel, so we can switch to that. And I actually have one question, well, two from the community, and one is going to be perfect for this. So the Joven from the community wanted to ask, with the success of the pyRevit, how come Autodesk never make you a part of their team, never kind of showed any financial support, and how did you end up at McNeel? Can we just dive into that?
Yeah, yeah, yeah. I mean, I don't really know about Autodesk's intention. Talking to other people, I've gotten this comment a lot that Autodesk doesn't really support open source projects.
Mm-hmm.
I don't think it's their thing. They want a company to be representing that and supporting their customers and stuff like that. And I think as a corporation, they have a easier, a more legally sane way of dealing with an actual company. that makes a plugin and supports its customers and all that kind of stuff, versus like one guy there that sometimes writes this program and sometimes doesn't.
But have you talked to anyone on Autodesk? Are they,
Not really.
or they never even reached out to you?
No, no. Nobody reached out. We never really reached out. I wouldn't. I mean, I talk shit a lot about Autodesk all the time, so I wouldn't really expect them to reach out. But yeah. I
Yeah.
mean, they may be doing. Jean-Marc and the team, they're doing really good job with like branding pyRevit a little bit better as a sort of like a bigger group of programmers taking care of this. So they might actually have some success with this.
I hope that Autodesk is going to wake up and see the value in community. Because pyRevit, you started this as just a side project. It's been 10 years and it's still so popular. People keeping it alive. It's, I don't know. Someone recently wrote me that pyRevit is one of not many things that made them excited about Revit again. Because every time they go in Revit, they look for plugins and so on. And finally, they found pyRevit. He found a plugin, but it didn't do exactly like he wanted. Then he found out that he can hold Alt, click on the button, see the code. And
Oh yeah.
oftentimes, when you need this just tiny change, you look at the code, it's in Python, so it's pretty much English. You just need to, especially with AI, you just kind of give it to AI, say, like, I have this, I need this, what do I do? And without even code, you can start coding because it's just, you can replace a few lines. This is, I don't know, I'm very excited about pyRevit. I spent a couple years teaching people because, I don't know, I'm just excited.
Yeah,
Hope,
you've been doing a great job, man. I really appreciate. We all really appreciated the spreading of the word. Like I appreciate it not because you're talking about pyRevit, but I appreciate it because you are teaching people and helping people automate things that could potentially save a lot of time.
oh yeah.
And also, it sort of like starts introducing programming language to a lot of people that are scared of this. Like I always say, if you grew up and you used calculators, these days learn Python
Hmm.
because it's kind of the new calculator.
Yeah.
You wrote a bunch of functions, and it doesn't really need to be beyond that if you don't want it to be. It can just be a thing that you run in the command prompt, and you run some math in there and write a function and do your calculations, and you're done.
Hmm.
But just that flexibility, that familiarity of how machine works, it could provide this capacity to at least copy and paste the code into ChatGPT and understand the changes that it made to it.
Oh yeah, yeah, yeah. I think this is how majority of people get started with pyRevit nowadays. Because there are thousands of scripts. You just need to find the right one and yeah, try to change it.
Yeah, and start modifying it and stuff. You
And
asked another question about how I got to McNeel.
yep,
PyRevit had a conflict, a DLL conflict with this other project that McNeel was working on at the time, and we're still working on it. It's called Rhino inside Revit.
that's a good
So
one.
it was a DLL conflict when these two plugins were running on Revit. And Scott Davidson from McNeel, he texted me on LinkedIn and he's like, "Hey, like we got this conflict. Can we talk about it?" He noticed that I'm in Portland, so he's like, "You're close." I was like, "Yeah." There was a build conference going on, build workshop going on at the time. So I was like, "I'll be in Seattle for that." I met him there the first time. We sort of like walked around, helped people, try to figure stuff out. I think he liked something there in me. And
Hmm.
then a couple of months later, him and Bob came to Portland and they were visiting ZGF. And Scott was like, "Hey, do you want to meet Bob?" I was like, "Absolutely." So I had coffee with him and I actually took him to dinner. Took Bob and Scott to dinner. And apparently, I didn't know that Bob hates this. People like taking him to dinner and paying for his dinner and stuff like that.
Good start.
And I did all the wrong things. Like I dressed up, which also like that's not a Pacific Northwest thing. People don't dress up around here. So he didn't like any of that apparently. But I met them for coffee the next morning, and he asked me a question. He's like, what do you want to do?" And I was working as a BIM manager at the time. I was like, "Hey, this the BIM fascination of my life that I want to make tools and help other people use them and take care of them and all that kind of stuff." And he's like, "Hey, do you want to come work at McNeil and do that?" And I was like, "It's a great question. Let me think about it." I was going through an interviews with Airbnb at the time, trying to get into this like group that they were creating to create like prefab, automate prefab manufacturing and stuff like that.
Is it like software development or is it more like BIM
Yeah,
management?
yeah, software development, yeah. Um, to automate, certain things around like prefab houses and whatnot. And that project kind of died away really quickly after that. And I was in way over my head. Like the other people that worked on that project were, insanely good programmers, very technical people, that kind of stuff, with years of experience in these kind of things. So I was like going back and forth between whether I should accept that job or this job and whatnot. And I'm really happy in the day I got the McNeel job, because that's the sort of like that was the environment that I was looking for. It's chill, people are very nice. I've worked on a, fantastic application that's been around for 25 years. And there's a lot to do. You can write Python if you want to do it. You can write C Sharp if you want to write C Sharp. You can write C++ if you want to do that. So it's been great. That's how it got me into McNeel, a conflict with pyRevit.
No, it's funny that a simple bug brought
Yeah,
to you all this opportunity and meeting these people. You never know what's gonna open the next door for you. This is
yeah,
interesting.
yeah,
And what do you do in McNeel since you joined them? Can you share a little bit day-to-day life?
yeah, yeah. So when I started joining McNeel, I was supposed to be the Revit guy, because like nobody really at McNeel knew what Revit is. Um, Kike, Kike from Barcelona office, which is the main developer for Rhino inside Revit. He's the one that put Rhino inside of Revit first. He had the most experience with all of this because they created another plugin for Rhino. It's called Visual Arc. That's sort of like Vim for Rhino, and they've been selling that for years. So he understood a lot of these concepts. But no, nobody really had like production experience with Revit. So I was supposed to be the Revit guy. And then I started working on that project, and sort of like after a couple of months, this Python 3 thing happened, and I got way more excited about this. So I kind of slowly switched to that one, and we hired another person. His name is Jaffe, way better than me in Revit. A lot of years of experience doing actual manufacturing and stuff like that, doing a lot of like complex facade panels, those kind of stuff.
Is he a developer or like real like BIM manager without coding?
Well, he's a Revit guru, but at the same time, like he did a lot of automation in the stuff that he worked on, like especially with like Dynamo and whatnot, as far as I know. Like he
Hmm.
doesn't write code as much. I think he writes a little bit of Python and whatnot. But his biggest skill is that he knows how to juggle Revit to and make
Hmm.
it do the things that he wants to do. So now he supports everybody that is using Rhino inside Revit, which is fantastic because that took that load off of me. And it created a better dynamic between him and Kike at the same time. They bounce off ideas each other and sort of like go around it, which is great. It's very productive. And then I end up like the only thing I do is like I make icons for the Rhino inside Revit. That's pretty much the only thing I do. After that, it was just me and this new script editing infrastructure in Rhino 8, which is Python 3, Python 2, C Sharp as a scripting language, making plugins, Grasshopper 1, Grasshopper 2, running the stuff from the command, running stuff from Visual Studio Code outside of Rhino, Rhino Compute. Like this thing has everywhere Rhino is, the scripting is also.
And do you write a lot of code, or is it more like kind of thinking, laying out the roadmap?
There was more thinking and laying out the roadmap when I started on this. Not so much of that anymore because we kind of covered the whole landscape as much as, I could think of it. But these days it's mostly cleaning up the code that I wrote 4 years ago to get it to run faster. Now, during those cleanups, I break things again. Apparently I did, yeah, last night. So Rhino 9
Oh,
is a little bit broken this morning,
oh.
but the scripting stuff. But I'm gonna go fix that. But yeah, it's mostly like, writing not a whole lot of code, but replacing bad code with cleaner code that is more readable.
Hmm.
So, in 6 months when there's a bug there and I need to read that code, I can actually understand better what's going on here. That kind of stuff.
Okay, so pretty much maintaining the code base.
Yeah.
And was it hard to transition? So can you take to this moment you were just joining McNeel, you just started working with them. Was it like a really hard to go into this coding environment, or was it easy for you? Can you just
No,
share your
they just
experience?
they basically let you kind of figure it out, right? So there's not a whole lot of onboarding. I showed up at McKinsey and they're like, okay, hi, do you need a laptop? I was like, sure. And they're okay, buy one. So I got a laptop and they're like, we added you to the Rhino source on GitHub, so you can pull Rhino. And then here's a document on how you build Rhino. You go build Rhino, and you're like, oh, I built Rhino on my machine now. And you load Rhino, and there's nothing there, and it's just a viewport. And you're like, where are the tools? And you reach out on the Slack, and they're like, oh yeah, you have to load the plugins. So you go load all the plugins, and then they're okay. Now it's looking more like Rhino. And
I see.
then you're like, okay, so I want to make this change. How do I do this? How do I do that? So you start asking questions. You start focusing on the thing that you want to do and ask questions when you have a question.
Mm-hmm.
And then every once in a while, when you're happy with what you've done, you show up on these developer meetings that we have on Tuesdays. And we have a section that's called Show and Tell. And you go and show what you've done. And people talk about it, and some hate it, some love it, that kind of stuff. And you get some good feedback before you actually put it inside of Rhino.
It sounds a little bit like startup vibe, which is a really good one. When you kind of
Yeah,
start, the company is not that big, everyone is connected.
yeah.
And when you looked at the code, was it overwhelming to you or was it just fine? Is it like did you feel like it was on another level when you saw the code of McNeel, what they're doing with Rhino and all of that?
It very much varies, and that which part of Rhino it is, and who worked on that code, and all that kind of stuff.
Mm-hmm.
There's millions and millions of lines of code in there, obviously, right? So it's a lot of different modules. Like there's plenty of plugins that are all importer and exporter file formats. So it's like 40 plugins there that just now normal Rhino when I'm developing, like I don't even load those plugins because I'm not exporting and importing files. But there's a lot of code there. The geometry engine is huge. I don't know anything about it.
Mm-hmm.
The display engine is huge. I don't know much about it. There is a whole lot of other plugins. The parts of Rhino that I know most about is Grasshopper, Iron Python, the scripting stuff, a little bit of the display, the plugin logic, stuff like that.
Mm-hmm.
The only times that I've sort of like gone beyond these boundaries is like there's something that doesn't work and I need to go track it. So that takes me to like how the plugins are being loaded inside of Rhino. And I was like, oh, maybe that's where the problem is, that kind of. So I started reading the code in other areas of Rhino. But
Mm-hmm.
there's really no way of reading the whole code base unless you have something. Like this year in Rhino 9, I have a project that Steve sort of like helping me out with, and he's trying to get me into more of a display code inside of Rhino, which is great. So I can like create new tools in the Rhino. Like I want to create this tool that you can array an object over a curve. But then you
Mm-hmm.
have to be able to draw that curve and then select the object and array it and then
Mm.
provide some adjustments and all, and then display the things that you want to display about this array, that kind of stuff. And that's all C++. And that's the part of Rhino that I don't really know much about. So like I'm going to be asking a bazillion different questions from people as I'm dealing with this. Um, so it's a massive code base, and you kind of go around reading what you need.
Okay, you focus on one part at a time.
Yeah, and there's also like in this big software code bases, the software itself is a big chunk of the code base, but there's so much other code around it that's revolved around like building and generating documentation, and like making sure the builds on Linux and Windows and Mac are all built correctly, and like just general tooling around maintaining that software.
Mm-hmm.
So there's like a bunch of those things that you could work on too. Like we got people that they spend most of their time writing the tooling things around Rhino, not Rhino itself, but just making it build correctly on the ever-changing like Mac OS and that kind of stuff.
Yeah, so you make tools for your own team to be
Yeah,
better at writing
yeah,
tools for others, which makes
yeah,
sense.
yeah. Like for Rhino 9, Brian in the developer meeting, he was showing this other web application, sort of like that he made for us to be able to manage all these features that we have planned for Rhino 9, and we can see the progress.
Mm-hmm.
'Cause like these are really cool things that you have somebody at the office that can write a custom tool for you to look at this thing that you're trying to do, which is amazing. Like that's what I love about software. So you can create all these like custom tools.
This is what people also get excited about pyRevit, because majority don't even see themselves as programmers. They just kind of start by accident and then it just goes from there because they see, oh, I can create a tool.
Yeah, just notice like coming from me after all these years of writing programs and stuff like that. I still don't consider myself a programmer. Like I didn't go to computer science school. I don't know how many different sorting algorithms are out there. I just know that there are plenty. I don't know how to write the best sorting function for, or the best memory safe code and whatever. But I work inside of C Sharp most of my life, and C Sharp, if you know C Sharp, it handles a lot of those conditions for you. So I don't have to worry about like releasing memory. I'm like, okay, I can do this, and the .NET runtime will handle it. Or I don't have to worry about like my buffer when I'm making a web request or something like that. The library would handle that. Like it's a lot easier for us. There used to be a term when I was younger. They called it puzzle programmers. That you program by putting things together, which I feel like that's the majority of programming these days. Is that you use a bunch of libraries that are designed for that thing, and you put them together, and you make something else. And sort of like that's yeah. Like not a whole lot of us are out there writing new AI models from scratch, different
Oh
algorithms and
yeah,
all that.
definitely not. This is where all these memes come that programming without Stack Overflow would not be programming.
Yeah.
Because pretty much you just go there, copy, paste, whatever. With pyRevit, you don't need Stack Overflow. You just all have all these tools in front of you. Yeah. So can we jump quickly back to pyRevit? I just wonder how your thinking in programming changed. So could you explain the process of how you used to create pyRevit scripts like a decade ago and how you would create them now? Just kind of the brainstorming, the logic, how much you would focus to reusing, just these kind of general things.
Yeah.
How would you approach it, let's say?
This is something that I noticed as I was working on this Rhino stuff. I was like, I can see how engineers work, and I can see how us architects/designers work. The architecture school makes us very comfortable with iterative design. So you sketch something and like that doesn't work out, throw it out, do something else. And you're like, you draw this beautiful plan, and you're like, yeah, that's great. I'm gonna throw this whole thing out. That's my architecture professor would do this to me. He's like, we would do this just judgment session with him, and he would look at stuff, review session, and he would mark things up, and then he would turn it up in front of us, throw it in the trash, and like, go do it again.
Oh.
And it didn't make sense at first, but like they beat this into us. So if I write a function, the problem with me is that like there's no fear in me deleting it and rewriting it again. A lot of programmers write this and they're like, this works. Why are you changing this? I'm like, well, it reads better. They're like, yeah, don't do that. So that I kind of have to be careful about like which direction I'm going in. But I kind of this helps me like this design thinking wants to keep redoing things. So that's how I kind of end up working too. Like if I have PyRevit open and if I have Revit open and I'm doing something, I that's why I like creating an environment like PyRevit so much because I have that script beside me and I'm like I'm gonna do this and then hit play and like that didn't work out. Change it again, then change it again, change it. That iterative design, right? A lot of times like I can't for the life of me I can't figure out what the index in the loop is in any point in time because I'm not that good at math, so I have to like run this 5 different times. I'm like, oh, it goes like beyond the boundaries, it's not supposed to do that kind of stuff. So that repeating part helps a lot. um, the part that is almost necessary to do that is when you're creating a UI because you don't really see what you're trying to create. One of the things that I really liked about working in pyRevit with WPF was that Visual Studio had this like beautiful
Oh
editor,
yeah. Oh yeah,
and
I
you can
love
put
it.
the buttons where they're like choose the right colors, like border thickness, that kind of stuff, and make it look nice and pretty. I have a hard time doing it in Rhino because like we use a different framework that's called Eto, and Eto doesn't have a UI builder like that.
Is it also for the VPF, this designer?
So the ethos encapsulates and simplifies dealing with UI in different platforms. So if you write your UI code in Eto, when it's running on Windows, it'll use WPF at the back end. When it's running on Mac OS, you use the Mac OS UI stuff. When it's on
Okay,
Linux and
I
that kind
see.
of stuff. So you don't have to rewrite your code. There's a library that sort of like makes it consistent across all these different operating systems. But that library doesn't have like a whole other application for you to create beautiful windows with. So I kind of have to write the code and I have to build and run Rhino. Like that doesn't look right. Like do it again, do it again, do it again, which I find myself doing a lot. Like this iterative process still exists in my workflow these days. Partly because I think they just beat that into us. Um, as I've gotten better over time, like becoming a slightly better programmer, now I don't need to do that as often. Sometimes I surprise myself these days, and I write like I spend 45 minutes writing something, and then I compile it and run it, and it works. And I'm like, oh wow, I didn't really need to change anything. This is interesting. I've never been here before. Um,
This is the new territory.
yeah, this is like new territory for me. But that's I would say like the design approaches still exist as you're writing programs because you're really designing something. And you know I
Hmm.
gotta know all the boundary conditions on the first try. Then you're gonna run it, then you like, click a button and it crashes. I'm like, oops, I didn't think of that. Go back and change it, do it again.
I can relate to that. I remember when I started, I pretty much didn't know Python, and I would write like 5 lines of code. I go and print everything I just wrote, like print every variable and
Hmm.
see, okay, I write 5 more lines, print, and I always was printing back and forth. Then I started printing less and less, and also had the moment like you described, like I was coding maybe for 1, 2 hours, and I was like, oh man, I didn't print for so long. Went in there, printed, and somehow it worked. And I was like, I don't know
Yeah,
how it works. I don't know what's going on. I also had this
yeah.
kind of aha moment, like, wow, actually, it's possible to write code without printing every 5 minutes. Interesting.
Yeah, you start
Yeah.
to get as you become a better programmer, you start building these intuitions about like how things are supposed to work. Like intuitively at some point where your loops end and where the other part of the program starts and what values are at any point in time, that kind of stuff. You start
Hmm.
learning how to hold all of this in your memory um, as you're programming. And I think, it's good. And also print debugging is a very valid thing. It's great.
It works. I mean, in the end of the day, it works. It's fast. Yeah, I like it. All right. I can see that we have around 10 minutes left. I like to end the kind of every show with asking for advice for beginner programmers. Could you just give a few advices for beginners, intermediates, and where should they focus, let's say?
I would say there's something else that I was talking to a friend of mine a while ago, and I think that would be something that I suggest. If you're interested in writing programming, pick up Python and just learn the basics. Don't do anything crazy. Just learn what variables are and what loops are and what an if statement is and what's a list and what's that kind of stuff. Just the basics. So you get an
Hmm.
understanding of how a programming language just does the things that you tell it to. And then go find something that you want to do.
Oh, yeah.
I think that's the most important part. Like find a problem and like, I want to fix this.
Hmm.
And then go about create a project out of that and go about creating your application, the software that you're trying to do. I think that's the best way to learn any kind of programming language because also it's very
Agree.
rewarding at every step of the way, and you can make it as complicated as you want. Like let's say I want to design a car by writing programs, right? So the first iteration is not going to be me designing a car. The first iteration is going to be a tiny longboard with on four wheels,
Hmm.
four tiny wheels. That's going to be the first thing. So I'm like, oh, I got something working. It moves now. And then the second iteration is like, oh, I got a scooter now. It's a little, it's got a handle. I can tell it where to go. That kind of stuff. But that just the beauty of that iterative approach into this thing as you are getting better and as you're learning more, I feel like that's just the best way to do it. And it's just the least scary way to do it, I think, also.
Hmm.
Um, because like a lot of times when you show, I've done this before. Like I start teaching somebody Python and I show them this like giant landscape and they freak out. And then I
Hmm.
was like, yeah, that kind of makes sense. It's fun to me because I've known that landscape for a long time. So I
Yeah.
can take somebody around and be like, oh, look at this beautiful thing, look at this beautiful thing. But for them, it's like there's a lot of unknowns. So I think, yeah, that would be my suggestion. Like pick up just the basics. That's the half an hour YouTube video on how Python works. Just that. And then pick something that fun that you want to do.
It's actually very good timing. I'm actually working on a mini course for Python on YouTube right now. Perfect. But would you recommend people who are starting to kind of try to do something with pyRevit right away, or first take Python and try to make something, like with Python, like a little website, like a.
I would let them decide what they get excited about and want to do that. Like if they're working in Revit every day and they want to get excited about creating this little button that does that for them, that would be it. Or they might be excited they have seen like web applications. They're like, hey, I want to open an application in a browser and stuff like that. I think whatever that gets you excited is good. Because at the end of the day, it's very rewarding. You'll enjoy it. You have built something, and also you get to use that thing, which means that you'll find problems and you want to add stuff to it later, which continues this like search.
I think being excited is really important. This is because many people kind of keep doing it. You need this kind of spark, I would say, that to kind of keep it going, that keeps you excited to kind of open the code editor in the first place.
Yeah.
Because if you're kind of scared and you hate it, well, you're not going to go far. But once you get to the fun level, this is actually really exciting.
Yeah, learning, I feel like that learning and playing combination is incredibly important. You can't have learning without playing.
Yeah.
And playing doesn't happen without learning. As you're playing, you will inherently learn something because you're finding out new things about this thing.
Yeah.
That learning and playing pair, I think, is very important.
Well, getting to the end mark, it was really exciting to have you on the show. Can you tell people where can they find you, where they can reach out? Do you do something that you want to share?
Yeah, these days, to be honest with you, if you want me to respond to you quickly, send me an email or find me on McNeel forum. I'm at ehsan@mcneel.com. And my forum handle is Iran-Nejad, same as everything else that I've had before. So it's easy, just search for Ehsan on the McNeel forum, you'll find me there. And if you shoot me a message, if you DM me there, I'll see that message a lot faster because like I'm spending time on the forum every day. So you can reach me there. The forum is actually much better than email, to be honest with you. Because first of all, I see it faster. Second of all, you can upload samples and put videos and all that kind of stuff about the things that you're trying to do, which is great. If you think this is like super Revit specific, we have a forum for pyRevit forums that is structured exactly the same way as McNeel forum. It uses the same application backend. It's the same. You don't have to learn anything new. They work kind of the same. And also, I'm on LinkedIn. If you want to find me on LinkedIn, send me a message. I think these are about it. I'm trying to stay away from like Instagram and all the other time-consuming stuff. So I think these are the good ones.
Is there anything you want to share? The projects you're working on, something people should know about you?
We'll share some stuff in upcoming in like in about a couple of months about Rhino 9 stuff. But what I'm working on is cleaning up the script editor inside of Rhino 8 for Rhino 9, so it can run faster and with less memory, use less memory, and just all that kind of stuff. Stabilizing a little more, and then also getting into drafting and stuff in Rhino 9. So hopefully I will have a part in improving Rhino drafting features for Rhino 9, which is, a lot of fun for me, learning how to write C++ better this time around, and also, make something for architects that can use.
Right, man. Thank you very much for coming on the show.
I appreciate it, Eric.
It was a huge pleasure having you. Especially, I had to had pyRevit that on the show about pyRevit.
Thank you. I appreciate all of you guys using pyRevit and making tools and sharing with other people. I think it's incredibly important sharing all this software. Software really doesn't cost a lot to replicate. And sending these out tools to everybody else, it's great. I appreciate what you were doing for pyRevit a lot. Also, like teaching people how to write
Thank
code,
you.
getting excited about their own tools, all that kind of stuff. So, thank you,
Thank you.
thank you, everybody.
Thank you, everyone, for watching. Goodbye. Hi, real quick. If you're into pyRevit and you want to boost your skills in record time, then check learnrevitapi.com platform. You'll find free in-depth courses for any stage of your programming journey. You'll get access to pyRevit Basics, Pro, and Modern UI courses. Plus, you'll also get access to my code library and join my exclusive community for pyRevit developers. In the community, we can chat, discuss programming in Revit, and most importantly, you can ask for help when you need it the most. If that sounds interesting, go to learnrevitapi.com to learn more.